Hi friends, welcome back to my channel. I am Adarsh. I am studying Bachelor of Engineering in Sri Venkateswara College of Engineering, Bangalore. Today we discuss about the super heterodyne and diode detector, one of the topic in the subject Principles of Communication System. Let us come to the topic super heterodyne. A super heterodyne receiver uses a signal mixing to convert the input radio signal into a steady intermediate frequency that can be worked with more easily than the original radio signal that has a different frequency. Depending on the broadcasting station, the IF signal is then amplified by a strip of IF amplifiers and then fed into a detector that outputs the audio signal into an audio amplifier that powers the speaker. In this article, we learn about the working of super heterodyne and AM receiver or a super 8 are shot with the help of block diagram. We will see the block diagram in next topic. Most of the AM receivers found today are of a super heterodyne type because they allow for the use of high selectivity filters in their intermediate frequency stages, and they have a high sensitivity because the internal ferrite rod antennas can be used. So due to these filters in the IF stage, which helps them in getting rid of unwanted RF signals. Also, the IF amplifier strip providing high gain, good strong signal response because of the use of automatic gain control in amplifiers and SA of operation only controls volume, power switch and the turning knob. Here is the block diagram of super heterodyne AM receiver. To understand how it works, let us take a look at the super heterodyne AM receiver block diagram, which is shown below. This is the block diagram where we send the signal into the RF filter, and here is the mixer. It is added the heterodyne local oscillator and RF filter. In the first IF filter, it filters the signals and sent to the IF amplifier, and it is also sent to the second IF filter and second IF amplifier and the last third IF filter, and it's sent to the detector. The detector detects, and if any fault is there, it re back to the first IF amplifier. If it is correct, then it will send to the audio amplifier. We get the output through the speaker. Here are some different stages of the functions. First, RF filter. The first block is the ferrite rod antenna coil and a variable capacitor combo that serves two purposes. RF is induced into the coil, and the parallel capacitor controls the resonant frequency of it, as ferrite antennas receives the best when the resonant frequency of the coil and capacitor is equal to the station's carrier frequency. In this way, it acts as the input filter of the receiver. Next, heterodyne local oscillator. The second block is heterodyne, also known as a local oscillator. The frequency of the local oscillator is set. So either the sum or the difference of the RF signal frequency and the local oscillator frequency is equal to the intermediate frequency used in the receiver. Usually it is around the 455 kilohertz. Next come to the next function, mixer. The third block is the mixer. The RF signal and the local oscillator signal is fed into the mixer to produce the desired intermediate frequency. Mixers found in the common AM receivers output the sum. The difference of the LO and RF frequencies and the LO and RF signals themselves. Most often in simple transistor radios, the heterodyne and the mixers are made using a one transistor. In highly quality receivers, those that use a dedicated integrated circuits such as the TCA440. This is one of the integrated circuit chip. These stages are separate, allowing for more sensitive reception due to the mixer outputting only the sum and difference frequencies. In one transistor local oscillator mixers, the transistor operates as a common base Armstrong oscillator, and the RF taken from the coil wound and the ferrite rod. So separate from the resonant circuit coil, it is fed to the base. First IF filter. The fourth block is the first IF filter. In most AM receivers, it is a resonant circuit placed in the collector of the mixer's transistors with the resonant frequency equal to the IF frequency. Its purpose is to filter off signals with a frequency different from the IF frequency, because those signals are unwanted mixing products. So only we use the filters and don't carry the audio signal of the station we want to listen to. And next come to the first IF amplifier. It is the fifth block in the first IF amplifier. Gains of the 50 to 100 in each IF stage common. If the gain is too high, distortion can take place, and if the gain is too high, IF filters are too close to each other and not properly shielded, parasitic oscillation can take place. The amplifier is controlled by automatic gain control. Voltage from the demodulator AGC lowers the gain of the stage, causing the output signal to be roughly the same regardless of the input signal amplitude. In transistor AM receivers, the AGC signal is most often fed to the base and as a negative voltage. In a NPN transistor, pulling the base bias voltage lower reduce the gain. Let us come to the next second IF filter. It is the sixth block in the second IF filter. Just like the first one, it is a resonant circuit placed in the collector of the transistor. It only lets signal of the IF frequency, improving selectivity. And the second IF amplifier, the seventh block is the second IF amplifier. It is practically the same as the first intermediate frequency amplifier, except it is not controlled by AGC. This is only the difference between. And as having too many AGC control stages, it increases the distortions. And come to the third IF filter. Just like the first and the second one is a resonant circuit placed in the collector of this transistor. It only lets signals of the IF frequency, improving selectivity. It feeds the IF signal to the detector. And detector, the ninth block is the detector. It is usually in the form of a germanium diode or a diode connected transistor. It demodulates the AM by rectifying the IF, and its output there is a strong IF ripple component that is filtered out by a resistor capacitor and a low pass filter. So only AF component remains. It is fed to the audio amplifier. And audio amplifier, the 10th block is the audio amplifier. It is amplifies the audio signal and passes into the speaker. Between the detector and the audio amplifier, the volume control potentiometer is used. Last speaker, it is the last block. The speaker that outputs audio to the user. The speaker is sometimes connected to the audio amplifier through headphone jack that is disconnect the speaker when headphones are plugged in. Let us come to the next topic, AM diode detector. The diode detector is the simplest and the most basic form of the amplitude modulation. And amplitude modulation is signal detector, and it detects the envelope of the amplitude modulation signal. The AM diode detector can be built from just a diode and a few other components, and as a result it is a very low cost circuit block within a overall receiver. As a result of its cost and convenience, the AM diode envelope detector has been widely used for many years in the transistor portable radios. And this is the diagram for the envelope detector. It is a time constant assay must be chosen so that envelope variations can be followed. Let us come to the envelope for detector advantages. It is a low cost and a simplicity. Low cost, the diode detector only requires the use of a few low cost components. This made it ideal for use in transistor radios using the discrete components. Simplicity is using very few components. The diode AM detector was easy to implement. It was reliable and did not require any setup. And let us come to disadvantages. Distortion and the selectivity, fading and the sensitivity. In distortion, as the diode detector is a non-linear, introduced distortion onto the detected audio signal. And selective fading, it is one of the issue often experienced on the short and the medium wavebands where the AM transmission are located. Is that the selective fading, the diode envelope detector is not able to combat the effects of this the way that some other detectors are able, and a result distortion occurs when selectivity fading occurs. sensitivity, the detector is not as sensitive as some other types. So if silicon diodes are used, these have a turn on voltage of around 0.6 volts. As a result, germanium and Schottky diodes are used, which has a lower turn voltage around 0.2 to 0.3 volts. Even the use of the Schottky diode, the diode envelope detector still suffers from the 4 level of the sensitivity. These are the disadvantages of the envelope detector. Thank you, friends.